Hello students, welcome to Diksha Karnataka YouTube channel. KCET 2024 exam has been done, right? I hope you guys have done well. So in this video, I'm going to discuss the solution of KCET, solution of physics KCET 2024. Okay, the question paper set which I'm going to discuss is C2. Okay, you have different sets, right? That is, the orders of the questions are different, right? But you can tally the questions, right? Questions and options also, right? Isn't it? So tally the questions and calculate your scores. That's it. Okay. Yeah. Let's start. So the question number 1. In Young's double slit experiment, YDSC, okay, an electron beam is used to produce interference fringes of width beta 1. Okay, here they have used electron beams, right? Now the electron beam is replaced by beam of protons. Okay, here electron beam is replaced by beam of protons with the same experimental setup and same speed. Okay, experimental setup is same, that is the values capital D, small d all are same. Okay, and same speed, that is speed of the electron and speed of the proton beams are same. Okay, the fringe width obtained is beta 2. The correct relation between beta 1 and beta 2 is, okay, so here this question, actually this question is came from YDSC, right? But here we have to apply de Broglie wavelength concept, right? Isn't it? So we know that de Broglie wavelength lambda is equal to h divided by mv. What is mv? mv is momentum of the particle, right? Lambda is wavelength of the particle, isn't it? Okay, the speed of the proton and speed of the electron both are same, right? Isn't it? But mass of the proton is lesser than mass of the, mass of the electron is lesser than mass of the proton, right? Mass of the electron is lesser than mass of the proton, right? Isn't it? So as the value of, okay, so from this I can conclude that lambda is inversely proportional to mass of the particle, right? As the value of mass increases, lambda will be decreases, vice versa, right? If the value of mass decreases, lambda will be increases, right? Okay, we know that fringe width beta is equal to lambda d divided by d. What is capital D? Capital D is distance between the screen and the fringes. Okay, sorry, distance between the screen and the slit width. Okay, slits, distance between the screen and the slits, and small d is slit width. Okay, lambda is wavelength of the light used, right? Okay, so here we have used electron beam and proton beam, right? So from this I can conclude that wavelength of the electron is greater than wavelength of the proton, right? Why? Because mass of the electron is lesser compared to the mass of the proton, isn't it? So here beta is directly proportional to lambda, right? So again from this and from this I can conclude that beta 1 is greater than beta 2. Okay, so the correct option is D. Understood? Yeah. Next question. Question number 2. Light of energy E falls normally on a metal of work function E by 3. Here this is the metal surface. Okay. Here the energy of the incident light is E, right? So what is the work function of the metal? Work function of the metal phi equal to E divided by 3. The kinetic energy K of the photoelectrons are. Okay, we need to find the kinetic energy of the, here when the light consists of energy E falls on the metal surface, what happens? Electron will emit, right? Isn't it? Right? So the work function of the metal is E by 3, right? E is greater than E by 3, right? Definitely electron will emit. So electron has some kinetic energy K. So they are asking to find kinetic energy K, right? So apply photoelectric equation, that is conservation of energy theorem, right? Energy of the incident light is equal to kinetic energy of the photoelectron plus work function, right? That is the photoelectric equation, right? Yeah. So what is the energy of the incident photon? E equal to kinetic energy of the photoelectron K plus work function E by 3. So K equal to 2 E by 3. E by 3, sorry, E minus E by 3 is 2 E by 3. Okay, so does all electrons have same kinetic energy, that is 2 E by 3? No, right? Isn't it? So not all electrons have the same kinetic energy. Okay, maximum kinetic energy of the electron is 2 E by 3. Okay, some electrons may have lesser value of K also. Okay, so the kinetic energy of the photoelectrons lies between 0 to 2E by 3. Okay, 0 to 2E by 3, not exactly 2E by 3. So the correct option is C. Understood? Yeah. Next question. Question number 3. The photoelectric work function for photometal is 2.4 electron volt. Again, the question based on photoelectric effect, right? Okay, work function of the photometal is given, right? Among the 4 wavelengths, the wavelength of the light for which photo emission does not take place. Okay, so we need to check every option, right? Isn't it? Yeah, okay, let's check. So here, what is the work function? Work function phi equal to hc by lambda naught, right? So here we have to check every wavelength, right? Isn't it? So the energy of the incident light must be lesser than photoelectric effect. Then only, energy of the incident light must be lesser than the work function of the metal. Okay, then only the photoelectric effect does not take place. Okay, so what is hc? 1242 ev electron volt nanometer, right? So phi is equal to 1242 electron volt nanometer, right? Divided by here lambda naught. The first one 200 nanometer. Okay, 200 nanometer. So nanometer will get cancelled. Solve this. Here you will get 6.21 electron volt, right? 6.21 electron volt. 6.21 electron volt is greater than 2.41 electron volt, right? Sorry, 2.4 electron volt, right? Here photoelectric effect will takes place, right? Isn't it? So here we need to find the wavelength of the light so that the photo emission does not take place, right? So the first option is wrong. Look at the second option. Here second option, work function phi is equal to, sorry, energy of the incident light, right? Isn't it? Not lambda naught. Here this is just lambda only. Okay, this is just lambda. Okay, so this is E, not phi, E. Okay, sorry, this is just E. Here we are finding energy of the incident light. Energy of the incident light must be lesser than work function of the given metal, right? Okay, so we have checked first option, right? Let's check for second one. Here for second option, here this is A, right? For second option, here energy of the incident light E equal to 1242 electron volt nanometer divided by 300 nanometer, right? 300 nanometer. Here nanometer will get cancelled. So now 1242 by 300 is 4.14 electron volt. So which is greater than 2.4 electron volt, right? 2.4 electron volt, right? So photoelectric effect will takes place, right? Yeah. So now for third option, here 1242 energy of the incident light. Okay, 1242 1242 electron volt divided by 700 nanometer. Okay, here electron volt nanometer, right? Here nanometer will get cancelled. 1242 by 700 is 1.77 electron volt. Okay, so 1.77 electron volt is lesser than 2.4 electron volt, right? So for this wavelength, photoelectric effect does not take place. Okay, does not take place. So option C is the correct answer. 700 nanometer. Yeah. Next question, question number 4. in alpha particle scattering experiment, if v is the initial velocity of the particle, okay, v is the initial velocity of the particle, then the distance of the closest approach is d. If the velocity is doubled, then the distance of closest approach becomes, okay, it's a ratio type question, right, isn't it? From the distance of closest approach, if you know the concept of distance of closest approach, you can easily solve this. So okay, what is this here? This is the nucleus, right? Alpha particle having initial velocity u, right? So what is the kinetic energy? The kinetic energy will be half mv square, sorry, mu square, right? So here this is the point, right? This is the point. So at this point, the kinetic energy of the alpha particle completely converts into electrical potential energy or potential energy, right? So so this is the distance between nuclei and the alpha particle, right? So the distance at which the alpha particle's kinetic energy completely converts into electrical potential energy, so that distance is called as distance of closest approach. Okay, here the kinetic energy completely converts into potential energy, right, at the distance of closest approach. Yeah, that is at this point the kinetic energy of the alpha particle is 0, right, isn't it? Kinetic energy of the alpha particle is 0. Here the potential energy is, here electrical potential energy u equal to, here this is kinetic energy, electrical potential energy equal to k z e square divided by d, right? D is distance of closest approach. Yeah, so here k equal to u, right? Kinetic energy completely converts into electrical potential energy. So what is kinetic energy? Kinetic energy is half m into u square, right, or v square, right? Here they have given v, right, isn't it? So half m into v square equal to kz e square divided by d. Okay, so now here we need to find distance of closest approach, right? So d equal to kz e square into 2 divided by m into v square. Okay, so k is common, sorry, k is constant, 1 by 4 pi epsilon naught, z is constant, atomic number, e is charge of the electron, m is mass of the electron, right? Sorry, here charge of the electron, m is mass of the alpha particle, right? So all these things are constant, right? So from this I can conclude that d is inversely proportional to v square, right? D is inversely proportional to v square. So when the velocity of the alpha particle is v, the distance of the closest approach is d, right? So when velocity doubled, what is the distance of the closest approach? Here d dash divided by d is equal to, here v square divided by 2v whole square. So now d dash divided by d equal to v divided by v square divided by 4v square. V square will get cancelled. D dash equal to d divided by 4. So the correct option is D. Okay, yeah. Next question, question number 5. The ratio of area of first excited state to a ground state of orbit of hydrogen atom is, again the direct one, right, and ratio type question. In CET most of the time they ask ratio type question, right? Okay, so here we know that the radius of the nth orbit in the hydrogen atom, right, is directly proportional to square of the nth energy level, right, isn't it? So now area is pi into r square, area of the orbit is pi into r square, right, isn't it? So from this I can conclude that area A is directly proportional to n to the power 4, right? So Rn square will be equal to, Rn square is directly proportional to n to the power 4, right, isn't it? If you take square on both sides, this will be n to the power 4, right? Okay, so they are asking ratio of the first excited state, that is n equal to 2 to n equal to 1, that is the ground state, which is equal to 4 to the power 4 by 1 to the power 4. Okay, so now A2 is to A1 equal to 16 is to 1. So the correct option is D. Okay, yeah. Next question, question number 6. The ratio of volume of aluminium, this is aluminium, not AI, okay, aluminium 27 nucleus to its surface area is given R naught equal to 1.2 into 10 to the power minus 15 meter, right? Okay, what is the volume of the aluminium nucleus? So that will be 4 by 3 pi r cube, right? Isn't it? So 4 by 3 pi r cube divided by area of the surface area of the aluminium is pi 4 pi r square, right? So this is the ratio of the volume of the aluminium to the surface area of the aluminium, right? Okay, so here r square will get cancelled, 4 pi will get cancelled. Now V divided by A is equal to R divided by 3. R is the radius of the aluminium, right? So radius of the aluminium R is equal to R naught into a to the power 1 by 3, right? R naught into a to the power 1 by 3. Right? R naught into a to the power 1 by 3. R naught is empirical value, right? 1.2 into 10 to the power minus 15 meter. A is atomic number of the aluminum, that is 27, which is given, right? Okay. So now here the ratio V divided by A, volume of the aluminum to the surface area of the aluminum, is equal to R naught. R naught is 1.2 into 10 to the power minus 15, and a to the power, a to the power 1 by 3, that is 27 to the power 1 by 3. Cube root of 27 is 3, right? So here 3 and 3 will get cancelled. Now V by A is equal to 1.2 into 10 to the power minus 15 meter. So the correct option is D. Okay, yeah. Next question, question number 7. Consider the nuclear fission reaction. The neutron, okay, neutron hits the uranium 235, and now it forms barium and krypton plus 3 fast neutron, right? Assuming all the kinetic energy is carried away by the fast neutrons only, and total binding energies of uranium 235, barium 144, krypton 89 to be 1800 mega electron volt, 1200 mega electron volt and 780 mega electron volt respectively. The average kinetic energy carried by the fast neutron is, okay, the simple, right? Here we need to find average kinetic energy of the fast neutron. That is, first find the Q value, then divide by 3, that's it. So they are asking average kinetic energy carried by the fast neutron, right? So there are 3 neutrons, right? 3 fast neutrons. So we need to find average kinetic energy. So find the Q value and then divide it by 3, that's it. So what is the Q value? Here the Q value is 1200 mega electron volt plus 780 mega electron volt minus 1800 mega electron volt, right? So now Q is equal to this will be 1200 plus 780 is 1980, right? Minus 1800, that is 180. So 180 mega electron volt, right? So we need to find average kinetic energy, right? Average kinetic energy of the fast neutron is 180 mega electron volt divided by 3, which is equal to 60 mega electron volt. Okay, so the correct option is D. Okay, 60 mega electron volt. Okay, next question, question number 8. The natural logarithm of the activity R of a radioactive sample varies with time t as shown in figure. Okay, here this is the natural ln of R and t time. Okay, t time graph. Okay, at t equal to 0, there are n naught undecayed nuclei, then n naught is equal to, take e square equal to 7.5. Okay, so this one is little bit trickier question, right? Isn't it? But you know the concept, right? You know the formula. So what is the radioactivity formula or activity formula? Not radioactivity, activity formula. So what is the formula of the activity? R equal to lambda n naught into e to the power minus lambda t, right? R equal to minus dn by dt, minus dn by dt is equal to lambda n naught into e to the power minus lambda t, right? Isn't it? That is activity, isn't it? So now take natural log or log on both sides. Okay, so now ln of r is equal to ln of lambda into n naught into e to the power, sorry, plus ln of e to the power minus lambda into t. Okay, so now ln of r is equal to ln of lambda into n naught minus here natural log of e to the power x is x only, right? Here x is minus lambda t, so minus lambda into t, right? So we got this equation, right? So now here look at the graph. This is the straight line, right? So what is the straight line equation? Y equal to mx plus c, mx plus c. So now compare this equation y equal to mx plus c to this equation, that is ln of r equal to ln of lambda n naught minus lambda t, right? So what is the slope here? The slope will be minus lambda, right? The slope m equal to minus lambda, right? Isn't it? So at t equal to 0, we need to find the value of lambda naught, right? So at t equal to 0, ln of r is equal to ln of lambda into n naught, right? Ln of r is equal to ln of lambda into n naught, right? So what is ln of r at t equal to 0? It is 2, right? It is 2, right? So now here 2 equal to ln of lambda into n naught, right? So now e square, take antilog on both sides, e square equal to lambda into n naught. So n naught equal to e square divided by lambda, right? So what is lambda? Lambda is slope, right? Isn't it? Take the slope. Slope will be here 2 minus 1, right? Y by x, dy by dx, right? So here 1 divided by 10 into 10 to the power 3, right? Isn't it? So 1 divided by 10 into 10 to the power 3. So n naught is equal to e square is 7.5, right? Into 1 by 1 by 10,000 is 10,000 only, right? Isn't it? 10,000. 10 into 10 to the power 3 is 10,000. So the value of n naught I am writing here, n naught at t equal to 0 is 75,000. So the correct option is C. Okay? Yeah. Next question, question number 9. Depletion region in an unbiased semiconductor diode is a region consisting of, okay, in depletion region, so there will be no immobile electrons, okay, or immobile charge carriers. So neither free electrons nor holes, okay. So option B is the correct answer. Direct question, right? Memory based question. Question number 10. The upper level of valency band and lower level of conduction band overlap in the case of, okay, upper level of the valency band and lower level of the conduction band overlaps in the conductor, okay. In semiconductor it does not, in semiconductor and insulators it does not overlap, okay. So silicon, here silicon is a semiconductor, germanium is a semiconductor, carbon is an insulator, okay. Allotropes of carbon, some allotropes of carbon are conductors, okay, but carbon is an insulator. So option C is also wrong. So the correct option is B. Copper is a conductor, right? In conductor, valency band overlaps with the conduction band. Yeah. Next question, question number 11. In the diagram shown, the Zener diode has a reverse breakdown voltage Vz. The current, okay, the current through the load resistance RL is IL. The current through the Zener diode is, okay, the current through the Zener diode is, sorry, the current through the load resistance is RL, resistance RL is IL. the current through the Zener diode, right? Okay, so what is the total current? The total current is equal to Iz plus IL, right? So here the total current is I, here this will also be I. So at this point the current will divide IL and Iz, right? Isn't it? Okay, so now applied potential is V naught, right? So V naught, the applied potential V naught is equal to potential difference across Rs, that is I into Rs, okay, potential difference across Rs plus potential difference across either Vz or RL, both are in parallel, right? Vz and RL are in parallel, right? So the potential difference across Vz is same as RL, right? So IL, V naught equal to I into Rs, that is potential difference across Rs and Vz, right? So I can write it as here Iz, this will be Vz only, okay? This will be Vz only. Vz, okay, Vz. So now V naught minus Vz is equal to I into Rs, right? Now I equal to V naught minus Vz divided by Rs. So what is I? I is Iz plus IL, right? Iz plus IL is equal to V naught minus Vz divided by Rs. Now the current through the Zener diode is V naught minus Vz divided by Rs minus IL. So the correct option is D. Okay. Yeah. Next question. Question number 12. A PN junction diode is connected to a battery of EMF 5.7 volt in series with a resistance 5 kilo ohm. Okay. Such that it is forward biased if the barrier potential of the diode is 0.7, neglecting the diode resistance, the current through the circuit is. Again, the simple one, right? First find the potential difference across the PN junction diode, right? So then divided by the applied the resistance which is connected in series, right? Okay. So what is the potential difference across the resistor? So that will be 5.7 volt minus 0.7 volt, right? Potential difference across the resistor. So V equal to, okay, so this is volt. So V equal to 5 volt, right? So now the current through the resistor I equal to here 5 volt divided by resistance 5 kilo ohm, right? 5 into 10 to the power 3 ohm. So 5 will get cancelled. I equal to 1 milliampere. So the correct option is B. Okay. Yeah. Next question. Question number 13. A particle of mass 500 gram is at rest. It is free to move along the straight line. Okay. The particle is free to move along the straight line. The power delivered to the particle varies with time according to the following graph. The momentum of the particle at t equal to 5 seconds is. Okay, at t equal to 5 seconds, here we need to find momentum of the particle, right? Here power and time graph is given, right? Isn't it? So we know that power is equal to energy divided by time, right? So energy is equal to power into time t, right? So from this and from this graph, so I can say that the graph, the area of this graph, okay, area under this curve or area under this straight line is energy. Area under this line gives us energy, right? So what is the area? Here the area will be, area under this graph will be, first let's find the area of the triangle. Okay, so half into base is 5 and height is 6, right? Plus area of this rectangle, so that will be here 2 into, right, 2 into 5. So now A equal to, here 2 3s are 6, right? So 15 plus 10, 25, right? So 25 joule, which is equal to energy, right? Energy is 25 joule. So we know that energy E equal to mv square by 2, right? mv square by 2, or we can write it as p square by 2. What is p? Momentum. P square by 2m. Okay, p is momentum, momentum squared divided by 2m, right? So momentum p is equal to root of, here I will write it in small letter, okay, p equal to 2me. So p equal to root of 2 into m is 0.5 kg into E is 25. So now solve this, you will get 5 Newton second. So the correct option is C. Okay, yeah. Question number 14. The dimension formula for activity of a radioactive substance. The direct question, right? So what is activity? Activity R equal to lambda n naught e to the power minus lambda t, right? So what is lambda? Lambda is okay, n naught is the initial number of the atoms present in the nuclei, right? Sorry, nucleus, right? Sorry, initial number of the nucleus or atoms present in the uh, given material, right? Isn't it? And or given radioactive substance, okay? Given radioactive substance, and lambda is decay constant, right? N naught doesn't have any dimension, and e to the power minus lambda t is constant, right? It doesn't have any dimension, right? Okay, so lambda is ln of 2 divided by half life. Here the dimension of half life is time t, right? T only, right? So these two are constants, right? N naught and e to the power minus lambda t is constant. So the dimension formula of activity R is equal to the dimension formula of lambda, that is t to the power minus 1, right? That is m to the power 0, L to the power 0, t to the power minus 1. So the correct option is C. Okay, yeah. Next question, question number 15. An athlete runs along a circular track of diameter 80 meter. 80 meter. So let us draw the diagram. Okay. So this is the circle. Okay. The diameter is 80 meter. Okay. So the radius will be 40 meter. Right? Radius will be 40 meter. 40 meter and 40 meter. Okay. The distance traveled and the magnitude of the displacement of the athlete when he covers 3 by 4th of the circle is. Okay, he covers 3 by 4th of the circle, right? Isn't it? So 3 by 4th of the circle, this much. Okay. He covers 3 by 4th of the circle. So when he covers 3 by 4th of the circle, we need to find the magnitude of the displacement and the distance, right? Okay, so now what is the magnitude of the displacement? Here, let us find the magnitude of the displacement. So this is the magnitude of the displacement, right? So this is the starting point A and end point B, right? So this is the magnitude of the, so this is displacement, right? So let us find magnitude of the displacement. So this angle is 90 degree, right? So this is right angle triangle, right? Base is 40 meter, height is 40 meter, right? So what about the hypotenuse? Hypotenuse will be 40 into root 2 meter, right? So the displacement is 40 into root 2 meter. Okay, let us find the distance, right? So distance is actual part taken by the object, right? So the white one, the white colored one is the distance, right? So here the angle, this angle is 3 by 2 pi, right? Angle is 3 by 2 pi. So what is the arc length of this one, the white colored one, right? So the arc length here, L is equal to theta into R, right? So that is equal to distance, right? Isn't it? So distance equal to theta, that is 3 by 2 pi into 40, right? So 2 20s are 40. So 20 into 3 pi is 60 pi. So the answer will be 60 pi meter. So distance is 60 pi meter, displacement is 40 into root 2 meter. Okay, magnitude of the displacement is 40 into root 2 meter. So the correct option is A. Okay, yeah. Next question, question number 16. Among the given pair of vectors, the resultant of two vectors can never be 3 units. The vectors are, again the direct question, right? Isn't it? So the resultant of the vector varies from maximum, varies, the range will be maximum to minimum, sorry, minimum to maximum, right? Minimum to maximum. Here the resultant of the two vector varies from minimum to maximum, right? Isn't it? So there are two vectors, okay, let's say A and B. So what is the minimum value of the resultant of those two vectors? That will be A minus B, right? So what is the maximum value of the resultant of those two vectors, A plus B, right? Isn't it? So now check, right? So the first one, 1 and 2 unit. Okay, so here if A is 2, okay, B is 1, so then 2 minus 1 is 1. Okay, so it varies from 1 to 3. Yeah, it can be a 3 vector, 3 units, right? The resultant vector can be a 3 units, right? Isn't it? So here we are asking, they are asking, among the given pair of vectors, the resultant of two vectors can never be 3, right? So option A is wrong. Let's check option B. A is 5, B is 2. So 5 minus 2 is 3, right? So option B is also wrong, right? Because it can be a 3, right? I mean 3 units, right? The resultant of the two vectors can be a 3 units, right? Then the maximum is 7 units, right? But minimum is 3 units, right? It can be a 3 units. So option B is wrong. So we need to find never be a 3 unit, never be 3 units. Yeah. Option C, 6 minus 3, 3. Yeah, again wrong, right? 6 plus 3 is 9, 6 minus 3 is 3. And option D, 8 minus 4, that is 2 units, and 8 plus 4, 12 units. Yeah, option D is the correct answer. Here the resultant of these two vectors can never be 3 units. Okay, so option D is the correct answer. Yeah. Next question, question number 17. A block of certain mass is placed on a rough inclined plane. The angle between the plane and the horizontal is 30 degree. So this is the rough inclined plane and this is the horizontal. So angle of inclination is 30 degree. The coefficients of static and kinetic frictions between the block and the inclined plane are 0.6 and 0.5 respectively. Then the magnitude of the acceleration of the block is, okay, we need to find magnitude of the acceleration of the block, right? Take g equal to 10 meter per second square. Okay, so here let us find the angle of repose. Okay, let us find the condition for or limiting friction condition. Okay, limiting friction or the condition for rest or moving with constant speed. Okay, so what is that condition? Tan theta equal to mu, the angle of repose, right? Tan theta equal to mu. So what is theta? Theta is 30 degree. So tan 30 degree is equal to mu. So what is tan 30 degree? So 1 by root 3. 1 by root 3 equal to mu. So mu equal to 0.57. 57 and so on, right? 0.57. See, the angle of repose, which is lesser than the static friction, right? Angle of repose is lesser than static friction, right? Isn't it? So therefore the block does not move, right? Isn't it? Block does not move. The static friction is greater than the angle of repose, right? Isn't it? So the block does not move, right? So the acceleration of the block is 0. So the correct option is B. That's it. Okay. So here you have to use the logic. That's it. Yeah. Next question. Question number 18. The ceiling fan is rotating around a fixed axle as shown. The direction of the angular velocity. Okay, we need to find direction of the angular velocity, right? Okay, what is angular velocity? Angular velocity in vector form, omega vector equal to r vector cross v vector, right? R vector cross v vector. So now apply right hand screw rule, right? So first put your all fingers directing towards R, right? So this is R, right? R is moving outward from the plane, right? The radius, right? R, and then the speed is in this way, right? So now curl your fingers towards V, right? Curl your fingers towards V, isn't it? Thumb represents direction of the angular velocity. So now what is the direction of the angular velocity? It is in downward direction, right? That is minus k cap. So the direction of the angular velocity is minus k cap. So the correct option is D. Okay, yeah. Next question, question number 19. A body of mass 1 kg is suspended by a weightless string which passes over a frictionless pulley of mass 2 kg as shown in the figure. The mass is released from a height of 1.6 meter, okay, 1.6 meter from the ground. With what velocity does it strike the ground? Okay, we need to find with what velocity does 1 kg block hit the ground, right? So here, which concept we need to apply? Here we need to apply the conservation of energy theorem, right? Isn't it? So why we are applying conservation of energy theorem? Here our system is pulley and 1 kg block, right? Isn't it? So is there any external force or external torque acting on our system? No, right? Isn't it? So there is no external torque acting on our system, right? So we can apply conservation of energy theorem, right? No, there is no external torque and external force acting on our system, right? So we can apply conservation of energy theorem. Okay, so what is the conservation of energy theorem? Initial total energy equal to final total energy, right? So what is the initial total energy, right? Initial total energy is potential energy of the 1 kg block, that's it, right? Initial total energy is potential energy of the 1 kg block and there is no movement, so kinetic energy is 0, right? Isn't it? So this is initial total energy, which is equal to the final total energy. Okay, I will write it here. Initial total energy is equal to final total energy. Initial total energy is mgh. Now what is the final total energy? Final total energy is kinetic energy of this block, okay, kinetic energy of this block plus rotational kinetic energy of the pulley, right? The pulley is rotating, right? Isn't it? So rotational kinetic energy of the pulley plus translational kinetic energy of the block. So what is the rotational kinetic energy of the block? So that will be half m into v square, okay, half m into v square. V is the velocity of the block when it hits the ground, okay, plus what is the rotational kinetic energy of the this one, the pulley, right? So that will be half into I into omega square, right? Half into I into omega square, right? So now I is moment of inertia of the pulley, right? Moment of inertia of the pulley is mr square, right? Isn't it? It is a disc. So moment of inertia of the disc about this axis is mr square, right? So now m gh is equal to half mv square plus half mr square, capital mr square, okay, capital mr square into omega square is v square by r square, right? Omega is v by r, omega square is v square by r square. So r will get cancelled, right? So now mgh is equal to sorry, this is mr square by 2, okay, mr square by 2, not mr square. Here the moment of inertia of the disk is mr square by 2, not mr square, so that is for ring, sorry, mr square by 2. Yeah, mgh equal to half mv square plus here half mv square, capital M into v square divided by 2, right? We need to find the value of v, right? Isn't it? So now take 1 by 2 as common, So now take 1 by 2 to the other side. So now here 2 mgh divided by m plus m by 2, right, or m by 2 plus m, right, which is equal to v square. So now v square or v, okay, v equal to, here v equal to 2 into m is 1 kg, small m is 1 kg into 10 into h is 1.6 divided by m by 2, that is 2 by 2, right. So 2 by 2 is 1, right, 1 plus 1, that is 2. Okay, I will write it here directly, 2 to the power 1 by 2. So 2 will get cancelled, right. So v equal to root of 16. So root of 16 is 4. So 4 meter per second. Okay. So the correct option is D. Understood? Yeah. Next question, question number 20. What is the value of the acceleration due to gravity at a height equal to half the radius of the earth from its surface? The simple one, right? Isn't it? So here the acceleration due to gravity g dash is equal to gm divided by r plus h whole square, right. So what is h? H equal to r by 2, right, half of the radius of the earth, right. So now gm divided by r plus r by 2 whole square. R plus r by 2 whole square is 3r by 2 whole square. 3r by 2 whole square is 9r square by 2. So now g dash is equal to 2 gm divided by 9r square. So what is gm by r square? Gm by r square is acceleration due to gravity on the surface of the earth, right, or near to the surface of the earth, right. Sorry, this is 4 by 9, not 2 by 9, 4 by 9. So 3r square by, sorry, 3r by 2 whole square is 9r square by 4. Okay. So 4gm by 9r square. Now g dash equal to 4 by 9 times g. So what is the value of g? G is 10 meter per second square on the surface of the earth. So now g dash is equal to 4 into 10 divided by 9. Now solve this, you will get g dash equal to 4.4 meter per second square. So the correct option is A. Okay, sorry, the correct option is A. Okay, yeah. Next question, question number 21. A thick metal wire of density rho and length L is hung from a rigid support. Okay, thick metal wire. The density of the metal wire is rho. Okay, the length of the metal wire is L. Is hung from a rigid support. The increase in length, okay, the increase in length of the wire due to its own weight is, okay, increase in length of the wire due to its own weight is y equal to Young's modulus of the metal of the wire. Okay, so now how to solve this question, right? Here the weight is in downward direction, right? Due to its own weight, the length increases, right, isn't it? So weight is the gravitational force, right? So apply gravitational force, then work done equal to F into dx, right? So then you have to integrate. So from that you will get the answer. The increase in length delta L equal to mgl divided by 2ay. Okay, mgl divided by 2ay. So what is m? M is mass of the wire. Okay, so mass of the wire, m equal to density of the wire into velocity of, density of the wire into volume of the wire, right, isn't it? Mass equal to density into volume, right? So now increase in length of the wire due to its own weight is equal to mass of the wire is density of the wire into, what is the volume of the wire? Volume of the wire is area of the cross section into length L, right? Area of the cross section into length L into G into L divided by 2ay. So a will get cancelled. So here delta L is equal to rho g L square divided by 2y. rho g L square divided by 2y. So the correct option is B. Okay. Question number 22. Water flows through a horizontal pipe of varying cross section at a rate of 0.314 meter cube per second. Okay. Okay. So here, this is the first horizontal cross section. Okay. Area of this cross section, A. Okay. The rate at which water flows is A into V, which is equal to, V is velocity of the flow of water, which is equal to 0.314 meter cube per second. The velocity of the water at a point where the radius of the pipe is 10 centimeter. Okay, let's say this is the cross section of the wire, another cross section of the pipe. The radius of this cross section is 10 centimeter. Okay, so what about the area? Area will be pi r square, right? So pi into r square, that is 10 into 10 to the power minus 4, right? 10 into 10 to the power minus 4 is 10 to the power minus 3, that is 0.001, right? Yeah. So okay, we got the area of the cross section of the wire. We need to find the speed of the water flow flows through this cross section, right? Isn't it? Okay, so apply equation of continuity, right? Isn't it? So volume of the, or the rate at which water flows through this cross section, that is AV1, is equal to the rate at which water flows through the second second cross section, right? So AV2. So AV1 is 0.314 meter cube per second, which is equal to AV2. AV2 is pi into 10 to the power minus 3 into V2. Okay, so now we need to find V2. So V2 is equal to 0.314 divided by pi into 10 to the power minus 3, right? So V2 equal to, here pi into 10 to the power minus 3 will be, so this will be 0.00314, right? So here this will be 10 meter per second. Okay, 10 meter per second. Actually, this cross section is, the area of this cross section is lesser than this one. Okay, actually this has to be the diagram, right? This has to be the diagram, not this one. Okay, so here this is AV1, okay, and this is AV2. So this has to be the diagram, not this one. Okay, this one is wrong, that is the diagram. Yeah, correct diagram. So V2 equal to 10 meter per second, so the correct option is C. Understood? Yeah. Next one, question number 23. A solid cube of mass m at a temperature theta naught is heated at a constant rate. It becomes liquid at a temperature theta 1 and vapor at temperature theta 2. Let S1 and S2 be the specific heats in its solid and liquid states respectively. If LF and LV are the latent heats of fusion and vaporization respectively, then the minimum heat energy supplied to the cube until vaporized is. Okay, so now heat energy supplied, okay, to a solid cube, right? Now the solid cube becomes liquid, right? Isn't it? So now the heat energy supplied is equal to m into LF plus m into LF plus m into S1 into theta 1 minus theta naught, right? So this is the heat energy required to convert solid cube to liquid, right? So next, heat energy required to convert liquid to vapor, right? So that will be m into LV plus m into S2 into theta 2 minus theta 1. Okay, so now add these two heats. So now we will get here the total Q is equal to m into LF plus m into S1 into theta 1 minus theta naught plus m into LV plus m into S2 into theta 2 minus theta 1. So the correct option is C. Okay, the correct option is C. Next one, Question number 24. 1 mole of an ideal monoatomic gas is taken round the cyclic process MNOM. The work done by the gas is the direct question, man. So what is the work done by the gas? Work done by the gas is area of this triangle, right? Isn't it? So work done by the gas is equal to area of this triangle, that will be half into so final volume minus initial volume, right? Final is 3 V naught, V naught, that is 2 V naught into 2 P naught, right? So 2 P naught. So now 2 will get cancelled. So now work done by the gas is equal to 2 P naught V naught. So the correct option is D. Okay, correct option is D. Next question, question number 25. The ratio of molar specific heats of oxygen is, again the direct one, right? The molar specific heat of oxygen, here the ratio of molar specific heat of oxygen, gamma equal to Cp by Cv, that is specific heat at constant pressure to the specific heat at constant volume. So oxygen is a diatomic gas, right? So for diatomic gas, the value of Cp is 7 by 2. For diatomic gas, right, the value of Cv for diatomic gas is 5 by 2. So 1 by 2, 1 by 2 will get cancelled. Gamma equal to 7 by 5, that is 1.4. So the correct option is A. Okay, yeah. Next question, question number 26. For a particle executing simple harmonic motion, that is SHM, at its mean position, velocity is 0 and acceleration is maximum. Absolutely wrong, right? Velocity is maximum, acceleration is 0. Here velocity is maximum, acceleration is 0. So option B, velocity is maximum, correct. Acceleration is 0, correct. So the correct option is B. Okay, yeah. Question number 27. A motorcyclist moving towards a huge cliff with a speed of 18 km per hour. Okay, so this is the huge cliff. Okay, and motorcyclist moving towards a huge cliff, right? And the speed is 18 km per hour. Sorry, 18 km per hour. Okay, what is the value of 18 km per hour in meter per second? So that will be 5. So 5 meter per second. Blows a horn of source frequency 325 hertz. Okay, the frequency of the source is 325 hertz, right? So that is F. If the speed of the sound in air is 330 meter per second, the number of beats heard by him. Okay, so we need to find number of beats heard by this man, right? Isn't it? Okay, or motorcyclist. Okay, so the wave will go and hit this cliff and it will come back, right? So what is the apparent frequency heard by the motorcyclist? So apparent frequency heard by the motorcyclist, f dash equal to f into here VA. VA is velocity of the sound in air divided by VA minus VS. VS is velocity of the source. Now f dash is equal to 325 into VA. VA is here, what is the value of VA? VA is 330 divided by VA minus VS, that is 330 minus 5, right? So this is the VS, right? Velocity of the source. VA minus VS is 325. So 325 will get cancelled. So apparent frequency heard by this guy is 330 hertz, right? Isn't it? So now here we need to find number of beats, right? Isn't it? Number of beats, here f double dash is equal to here number of beats, right? Isn't it? Number of beats equal to f dash minus f. What is f dash? 330 hertz. F is 325 hertz. So 330 minus 325, which is equal to 5. Okay, so the correct option is A. 28. A body has a charge of minus 3.2 microcoulomb. The number of excess electron it has. Okay, so the charge of the body is minus 3.2 microcoulomb, right? So we need to find the number of excess electrons in that body, right? So what is the magnitude of the charge on the body? 3.2 microcoulomb, right? So the Q is equal to N into E. We need to apply the conservation of, we need to apply quantization of charge concept, right? Isn't it? So what is the value of Q? Q is the charge on the body, right? Minus 3.2 micro is 10 to the power minus 6 coulomb, which is equal to N. N is the number of electrons on the body, okay, or number of excess electrons on the body, into E is charge of the electron, that is minus 1.6 into 10 to the power minus 19 coulomb. So now N equal to, here this will be 3.2 minus will get cancelled, right? 3.2 into 10 to the power minus 6 by 1.6 into 10 to the power minus 19. So this will be 2 and 10 to the power minus 6 by 10 to the power minus 19 is 10 to the power 13. So N equal to here 2 into 10 to the power 13. So the correct option is C. Okay. Yeah. Question number 29. A point charge of 10 microcoulomb and another point charge of B, point charge of A of 10 microcoulomb and another point charge of B of 20 microcoulomb are kept 1 meter apart. 10 microcoulomb A, okay, B plus 20 microcoulomb, both are kept apart by 1 meter. In free space, the electrostatic force on A due to B is F1 vector, okay, F1 vector, and the electrostatic force on B due to F2 vector, then okay, F1 is equal to minus 2F2. That is absolutely wrong. Here this one, the electrostatic force is action reaction pair, right? That is force on A due to B is same as force on B due to A, right? So force on A due to B is same as force on B due to A, but both are in opposite direction. So F1 vector equal to minus F2 vector. So the correct option is here B. Okay. Yeah. Question number 30. A uniform electric field E equal to 3 into 10 to the power 5 Newton per coulomb is acting along the positive y-axis. Okay. Here electric field is acting along positive y-axis. The electric flux through the rectangle of area 10 cm cross 30 cm, whose plane is parallel to the yx plane. Parallel to the zx plane, right? Okay. So this is y, x, and z, right? So now here this is the rectangle, 10 cm cross 30 cm rectangle. Okay, so these are the direction of the electric field. So what is the electric flux through this rectangle, right? The value of the electric field is 3 into 10 to the power 5 Newton per coulomb, right? So what is electric flux? Electric flux phi equal to E dot A, right? In scalar, phi equal to Ea cos theta. So what is theta? Theta is angle between electric field vector and area vector. So what is the angle between electric field vector and area vector? It's 0 degree, right? Why it is 0 degree? Because the direction of the A is same as direction of the E, right? E is perpendicular to this plane, right? Rectangular plane, right? And the direction of the A, or the A, is also perpendicular to rectangular plane, right? So theta is 0 degree, that is A and A both are in parallel. Theta is 0 degree, so phi equal to E into A. Okay, phi equal to E into A. So now substitute the values. E is 3 into 10 to the power 5 Newton per coulomb. Okay, in 3 into 10 to the power 5 Newton per coulomb into here. What is the value of A? A is 10 centimeter cross 30 centimeter. 10 into 30 is 300. Centimeter squared is 10 to the power minus 4 meter squared. So 300 into 10 to the power minus 4 is 3 into 10 to the power minus 2. So now phi equal to 9 into 10 to the power 3 voltmeter. So the correct option is B. Okay, yeah. 31st, the total electric flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is given epsilon naught equal to permittivity of free space, right? So here, this is the spherical surface, the dipole moment, electric dipole is inside this, enclosed by this spherical surface, right? Isn't it? Total electric flux passing through this spherical surface. The total electric flux passing through this spherical surface is 0. Why? Because net charge enclosed by this spherical surface is equal to 0, right? Why? Because net charge is equal to 0 inside the spherical surface. So the correct option is A. Okay. So phi equal to Q naught or Q net or Q enclosed divided by epsilon naught, right? Q net is 0. So phi equal to 0, right? Yeah. Question number 32. Under electrostatic condition of a charged conductor, which of the following statement is true? The first one, the electric field on the surface of the charged conductor, sigma by 2 epsilon naught. Wrong. It is sigma by epsilon naught, right? Where sigma is the surface charge density. Okay. The first option is wrong. Second one, the electrostatic potential inside the charged conductor is always 0. No, it is wrong. Inside the charged conductor, electrostatic potential is not 0. Okay. Any excess charge resides on the surface of the conductor. Correct. Excess charge always resides on the surface of the conductor. The net electric field is tangential to the surface of the conductor. Wrong. Net electric field is perpendicular to the surface of the conductor. So the correct option is D. Sorry, correct option is C. A, B, D are wrong. Okay. Next question. Question number 33. A cube of 1 centimeter contains 100 molecules, each having an induced dipole moment of 0.2 into 10 to the power minus 6 coulomb meter in an external electric field 4 Newton per coulomb. The electric susceptibility of the material is, okay, electric susceptibility Xi E is equal to ratio of the polarization by electric field, right? So what is polarization? The polarization is induced dipole moment per unit volume divided by E. So how many molecules are there? 100 molecules, right? Each having an induced dipole moment of 2 into 0.2 into 10 to the power minus 6, right? So into 100. Now electrical susceptibility Xi E equal to, here induced dipole moment is 0.2 into 10 to the power minus 6 into 100 divided by the volume is 1 centimeter cube. 1 centimeter cube is 10 to the power minus 6, right? So 10 to the power minus 6 into 4. So here take this as 2, right? Isn't it? So here 2 into 10 to the power minus 1, right? So this will be 2, right? So 2 50s are 100, right? 2 50s are 100. So now 10 to the power minus 6, 10 to the power minus 6 will get cancelled. So electrical susceptibility is equal to 5. So the correct option is B. Okay. Yeah. Next question. Question number 34. A capacitor of capacitance 5 microfarad is charged by a battery of EMF 10 volt at an instant of time. The potential difference across the capacitor is 4 volt. At an instant of time, the potential difference across the capacitor is 4 volt. Okay, remember, and the time rate of change of potential difference across the capacitor is 0.6 volt per volt per second. So dV by dt is equal to 0.6 volt per second. Then the time rate at which energy is stored in the capacitor at that instant, that is, we need to find the power, right? So now energy stored in the capacitor E equal to half CV square, right? Here the time rate at which energy stored in the capacitor, that is dE by dt. dE by dt is equal to half C into 2V into dV by dt. dE by dt equal to half C into 2V into dV by dt. Here 2 will get cancelled, right? So now the time rate at which energy stored in the capacitor dE by dt equal to CV into dV by dt. Now the rate at which energy stored in the capacitor dE by dt equal to C is 5 microfarad. So 5 into 10 to the power minus 6 into V. V is 4 volt. Here at an instant of time, the potential difference across the capacitor is 4 volt. Okay. So V is 4 volt, right? So V is 4 volt. 4 into dV by dt, dV by dt is 0.6, right? So now dE by dt is equal to, here 5 into 4 is 20, right? 20 into 0.6 is 12, 12 into 10 to the power minus 6 microwatt, right? So 12 into 10 to the power minus 6 minus 10 to the power minus 6 is micro, so 12 microwatt. So the correct option is A. Okay. Next question, question number 35. E vector is the electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J vector. The correct form of Ohm's law is, yeah. So here what is Ohm's law? Ohm's law, V equal to I into R, right? So I can write V, that is potential difference applied across the conductor, V as E into D, right? V as E into D, right? E into D, which is equal to I is current, right? So current will be current density J into area of cross section A into R, right? So here the resistivity is rho, right? The answer is in resistivity and conductivity also. Okay, so now the resistance, I can write resistance as rho into L. L is the length of the conductor, that is D. Okay, so D divided by A. So now A will get cancelled, D will get cancelled, right? So now electric field E vector E equal to J into rho. In vector form, E vector equal to J vector into rho, or J vector dot rho. Okay, so option C is the correct answer. E vector equal to rho dot J vector. Yeah. Next question, question number 36. In the circuit shown, the end A is at potential V0 and end B is grounded. The electric current indicated in the circuit is, okay, we need to find electric current here, this one. Okay, so now carefully look at the diagram here, circuit diagram. So this is Wheatstone bridge, right? These two are Wheatstone bridge connected in series, right? Two Wheatstone bridge connected in series. So now here I can redraw this diagram as like this, right? Yeah, V0. So R, 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 R. Here 2R, 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 and 2R, right? Okay. So now check whether these two Wheatstone bridges are balanced or not. So these two are balanced, right? Isn't it? Take the ratio R by R and R by R. Both are 1, right? Isn't it? These two are balanced Wheatstone bridge. So now you can neglect these two resistances, right? You can neglect these two resistors, right? That is R and 2R resistors. So now these two are in series, these two are in series, right? Then these two are in series, these two are in series, right? Then here RR and RR, these two are in parallel and parallel, right? So now here the equivalent circuit diagram, I will draw equivalent circuit diagram, the simple one, right? Series 2R, 2R, right? 2R and 2R. So this will be 4R and 4R. Okay, now 2R in parallel, right? Isn't it? So what is the net resistance then, or equivalent resistance? Then equivalent resistance will be 1 by 2R plus 1 by 2R. 1 by 2R plus 1 by 2R is R only, right? Here this will be 1 by 4R plus 1 by 4R, that is 2R, right? Net resistance will be 2R, right? Isn't it? So now here equivalent circuit diagram, here this will be R, 2R and V naught. Here the current is flowing, right? Isn't it? Okay, so now these two are in series, right? In series, current does not change. So now what is the equivalent resistance? Equivalent resistance will be 3R, right? So now what is the current flowing in the circuit? So the current flowing in the circuit, I equal to V naught divided by 3R. That's it. So the correct option is D, V naught divided by 3R. Okay, yeah. Next question, question number 37. The electric current flowing through a given conductor varies with time as shown in the graph below. The number of free electrons which flow through a given cross section of the conductor in the time interval t lies between 0 to 20 second is, okay, so this is the current versus time graph, right? So we need to find number of electron flow through a given cross section of the conductor in time interval t lies between 0 to 20 second. Okay, so this is the given graph, right? Isn't it? So area under this curve will be equal to, area under this curve will be equal to the charge which flown through the given cross section, right? Isn't it? So what is current? Current I equal to Q divided by T, right? So now Q equal to I into T, that is area under this curve is equal to the charge flown through the given cross section, right? So now what is Q? Q equal to N into E, N into E equal to I into T. So N equal to IT by E, okay, I into T by E. So what is I into T? I into T is area under IT graph, okay, area under IT graph. So now N is equal to what is the area under IT graph? So the first one, this one is triangle, right? So then the rectangle, right? And then again one rectangle. So two rectangles plus one triangle. Okay, let us find area of the triangle. Half into base, base is 10, height is 200, right? Half into base is 10, height is 200 milliampere, right? 200 milliampere, 100, 200, 300. 300 minus 100 is 200. 200 milliampere. So milli is 10 to the power minus 3. 200 into 10 to the power minus 3 is 0.2, right? Plus area of this rectangle, this one, right? So here the length is 10, the height will be 100, right? So 10 into 0.1 plus now area of this rectangle. So the here this will be, length will be 10 and the height will be 300, so 0.3. So 10 into 0.3, 300 milliampere is 0.3 ampere, whole divided by E is 1.6 into 10 to the power minus 19. Now solve this, you will get 3.125 into 10 to the power 19. So the correct option is A. Okay, yeah. Next question, question number 38. The IV graph for conductor at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, as shown in the figure. The temperature coefficient of resistance of the conductor about in per degree Celsius. Okay, I versus V graph is given, right? So we need to find the temperature coefficient, that is the value of alpha. Okay, alpha we need to find. Yeah, conductor is about. Okay, so let us find the resistance of the conductor, right? So now here this one is R2, okay, and this one is R1, right? R1 and R2. Okay. So now R1 is tan. Okay. Here the slope, right? Slope is tan 45 degree, right? So what is the slope? Slope is I by V. So what is I by V? 1 by R, right? Here the slope is equal to I by V, which is equal to 1 by R, right? So tan 45 degree is 1 by R1, right? And tan 30 degree is equal to 1 by R2, right? So now this will be R2 is equal to root 3, R1 equal to 1, right? Okay. So now here R2, that is the resistance at 400 degrees Celsius, right? So R 400, that is equal to R2, okay, which is equal to R naught into 1 minus alpha into delta T2, okay. Here R1 is equal to so this will be R 100 degrees Celsius, which is equal to R naught into 1 plus alpha into delta T1, right? So now divide R 400 by R 100, right? So now R 400 is root 3, right? Root 3 divided by 1 equal to, here anyway R naught will get cancelled. So 1 plus alpha into 400 divided by 1 plus alpha into 100. Okay. So now take 1 plus alpha into 100 to the other side, right? So now this will be root 3 into 1 plus alpha into 100 equal to 1 plus alpha into 400, right? 1 plus alpha into 400. So now we need to calculate the value of alpha, right? Okay. So now root 3 plus root 3 into alpha into 100, right, equal to 1 plus alpha into 400, right? So root 3, now multiply or take root 3 inside the bracket, right? So here this will be root 3 plus root 3 into alpha into 100 equal to 1 plus alpha into 400, right? Okay. So now here we need to find the value of alpha. So root 3 minus 1 equal to alpha into root 3 into 100 minus root 3 into 100 plus alpha 400, right? So alpha equal to root 3 minus 1 divided by 400 minus root 3 into 100. Root 3 into 100 is root 3 is 1.7 something, right? So 1.7 into 100 is 170. 170, 400 minus 170. So 400 minus 100 is 300. 300 minus 70 is 230, right? Alpha equal to root 3 minus 1. So this will be 0.7 divided by 230, right? Isn't it? 0.7 divided by 230. So alpha is approximately equal to so this will be 3 into 10 to the power minus 3. 3 into 10 to the power minus 3. So what is the SI unit? Per degree Celsius, right? Okay, so that's it. Okay, per degree Celsius. So the correct option is A. Okay, so the correct option is A. Next question, question number 39. An electric bulb of 60 watt or 120 volt is to be connected to 220 volt source. Okay, so here this is the bulb, okay, 60 watt and 120 volt rated values, right? What resistance should be connected in series with the bulb so that the bulb glows properly? Okay, here we need to connect the resistance in series with the bulb so that the bulb glows properly, right? So this bulb is connected to 120 volt supply, sorry, 220 volt supply, right? 220 volt supply. Now to bulb glow properly, the potential difference across the bulb must be equal to 120 volt. Okay, so then only bulb glow properly. Okay, so here what is the potential difference across the bulb? The potential difference across the bulb VB is equal to here V into RB divided by RB plus RS. What is the meaning of RB here? RB is resistance of the bulb and RS or R. Okay, here I am writing R. R is the resistance in series with the bulb. Okay, so what is V? V equal to 120 volt. Okay, so what is the value of RB? RB we need to find, right? Isn't it? Power and voltage rated values are given, right? Okay, so we know that power P equal to V square divided by VO square, this is VO square divided by RB. So now RB is equal to VO square divided by P. Okay, so now what is VO square? Here VO square is 120 squared, right? That is 120 into 120 divided by P, that is 60. So 62s are 120, so this will be 240. Okay, so now substitute the value of RB and the value of V, we will get the value of R, right? And potential difference across the bulb is 120 volt, right? So now here VB into RB plus R equal to V into RB, right? Isn't it? So now VB RB plus VB into R equal to V into RB. So now take VB RB to the other side, right? So now here R equal to V into RB minus VB RB divided by VB. So now substitute the values. Okay, R equal to V is 220 into RB is 240 minus VB is here 120 into RB is 240 divided by VB is here 120. So now solve this, you will get 200 ohm. So the correct option is C. Next question, question number 40. In an experiment to determine the temperature coefficient of resistance of conductor, a coil of wire X is immersed in a liquid. It is heated by an external agent. A meter bridge set up is used to determine the resistance of the coil X at different temperatures. The balancing points measured at temperatures T1 equal to 0 degree Celsius, T2 equal to 100 degree Celsius are 50 centimeter and 100 centimeter respectively. If the standard resistance taken out is S equal to 4 ohm, in both trials, the temperature coefficient of the coil is, okay, we need to find temperature coefficient of the coil, right? Okay, here when temperature T equal to 0 degree Celsius, okay, we know that for meter bridge R2 divided by R1 is equal to X divided by 100 minus X, right? R2 by R1 equal to X divided by 100 minus X. Yeah. Now R2 is resistance of the this one, okay, coil at 0 degree Celsius. Okay, resistance of the coil at 0 degree Celsius divided by 4. R1 is 4 ohm, okay, which is equal to X by 100 minus X. X equal to 50 centimeter. So 50 centimeter divided by 50. Okay, R at 0 degree Celsius equal to 4 ohm. Okay, let us find resistance at 100 degree Celsius, right? Now R at 100 degree Celsius divided by 4 is equal to X minus 100, X divided by 100 minus X. X divided by 100 minus X is 60 divided by 40. Okay, so 4 tenths are 40. So now 6, right? 60 by 10 is 6. So R at 100 degree Celsius is equal to 6 ohm, right? R at 0 degree Celsius is 4 ohm. R at 100 degree Celsius is 6 ohm. So now we need to find temperature coefficient. Now R at 100 degree Celsius is equal to R at 0 degree Celsius into 1 plus alpha into delta T. Delta T is 100. So 6 equal to 4 into 1 plus alpha into 100 degree Celsius, right? So now 2 2s are 4, 2 3s are 6, right? So now 3 by 2 minus 1 is 1 by 2, right? 1 by 2 equal to alpha into 100 degree Celsius, right? So now the value of alpha is equal to 0.005 per degree Celsius. So the correct option is C. Okay. Yeah, question number 41. A moving electron produces both electric field and magnetic field. Okay, so the correct option is B. Next question, question number 42. A coil having 9 turns carrying a current produces magnetic field B1 at the center. Okay, so this is the coil, it is having 9 turns and produces magnetic field B1 at the center, right? Now the coil is rewounded into 3 turns carrying same current. Okay, now coil is rewounded into 3 turns, right, carrying same current. Here the current I and current I. The magnetic field at the center B2 equal to, okay, we need to compare the magnetic field at the center B2 in the second coil to the first coil, right? Okay, so here the radius of the first coil is R, the radius of the second coil is here R dash. Okay, so now what is the circumference of the coil? 2 pi R. How many number of turns are there? 9, right? So in first case 9 into 2 pi R is equal to, in second case 3 turns are there, right? 3 into 2 pi R dash, 2 pi R dash. So now 2 pi will get cancelled, right? 3 3s are 9. So now R dash equal to 3R, right? R dash equal to 3R. R dash equal to 3R. So now magnetic field due to the coil at its center is mu naught into N into I divided by 2 into R, right? So for first one B1 equal to here B1 equal to mu naught into 9 into I divided by 2R. Okay, so for second one B2 is equal to mu naught into 3 into I divided by 2R dash. R dash equal to 3R, right? So here B2 divided by B1 is equal to, so this will be 3 mu naught I divided by 2R dash, right? So 2 times R dash, that is 3R whole divided by 9 mu naught I divided by 2R. So 2R will get cancelled, 3 will get cancelled, mu naught I will get cancelled. So B2 equal to B1 times 1 by 9. So the correct option is A. Okay, yeah. Next question, question number 43. A particle of specific charge Q by m equal to pi coulomb per kg is projected from the origin towards positive x-axis with the velocity 10 meter per second in a uniform magnetic field B vector equal to minus 2k cap Tesla. The velocity V vector particle after time t equal to 1 by 12 second will be. Okay, we need to find velocity V vector of the particle 1 by 12 second, right? Okay, let us find the time period. So time period equal to 2 pi m divided by qb, right? Time period of the particle is equal to 2 pi m divided by qb. So t equal to, here q by m is given pi, right? So m by q is 1 by pi. So 2 pi divided by pi into b. B is 2, right? So 2 pi will get cancelled. T equal to 1 second, right? T equal to 1 second. So we know that here theta equal to omega into t, right? Theta equal to omega into t. So now here theta equal to omega is 2 pi by t, 2 pi by t into t. T is 1 by 12, right? So what is the value of capital T? Capital T is 1 second. So 2 pi divided by 1 into 1 by 12. So which is equal to theta equal to pi by 6. That is the particle makes an angle pi by 6 with the x axis, right? Isn't it? So now velocity vector v vector equal to here v naught cos theta I cap plus v naught sin theta j cap, right? So velocity is 10 meter per second, right? So v vector equal to 10 into cos theta, that is cos pi by 6. Cos pi by 6 is root 3 divided by 2 plus v naught is here 10, right? 10 into sin theta, sin 30 degrees 1 by 2, j cap here I cap. So now solve this, you will get v vector equal to 5 into root 3 I cap plus j cap. Okay, root 3 I cap plus j cap. What is the unit? Meter per second. So the correct option is D. Okay, yeah, next question. Question number 44. The magnetic field at the center of the circular coil of radius r carrying current I is 64 times the magnetic field at the distance x on its axis from the center of the coil. Here, this is the coil. Okay, radius is r. So at its center, the magnetic field is B1. Okay. So here the current is I. Here I. At x, right? At distance x, the magnetic field B, right? Isn't it? Magnetic field is B2. Okay. Now B1 is equal to 64 times B2. Understood? Okay, so we need to find the value of x. We need to find, so this is point P. We need to find the value of x, that is the distance between point P and the center of the coil. Okay, so what is the expression of B1? B1 equal to mu naught I divided by 2R, right? So what is the expression of B2? Expression of B2 equal to mu naught I R square divided by 2 into r square plus x square to the power 3 by 2. Okay, if you don't know this expression, just go through the NCERT. The derivation is there. Okay, yeah. So now here B1 is mu naught I divided by 2r is equal to 64 times mu naught I r square divided by 2 into r square plus x square to the power 3 by 2. So now 2 will get cancelled, right? And then mu naught I will get cancelled. So now solve this. Okay, you will get x equal to r into root 15. X equal to r into root 15. So the correct option is D. Okay, yeah. Next question. Question number 45. Magnetic hysteresis exhibited by dash magnetic materials. Again, the direct question and memory based question. Okay, so magnetic hysteresis is exhibited by both para and ferromagnetic materials. Okay, so option D is the correct answer. Yeah, next one. The question number 46. Magnetic susceptibility of Mg, that is magnesium, at 300 Kelvin is 1.2 into 10 to the power minus 5. What is the susceptibility at 200 Kelvin? Okay, we know that susceptibility from the Curie's law, susceptibility of the material, okay, xi m, magnetic susceptibility of the material xi m is inversely proportional to absolute temperature, right? Magnetic susceptibility of the material is inversely proportional to absolute temperature. So now here for magnesium at 300 Kelvin, the magnetic susceptibility is 1.2 into 10 to the power minus 5, right? At 200 Kelvin, we need to find magnetic susceptibility. Okay, so now xi m at 200 Kelvin divided by xi m at 300 Kelvin is equal to 300 Kelvin divided by 200 Kelvin, right? So anyway, Kelvin get cancelled, 100 will get cancelled, right? So magnetic susceptibility at 200 Kelvin is equal to 1.2 into 10 to the power minus 5 into here 3 by 2 is 1.5, right? So xi m, which is equal to so this will be 1.8 into 10 to the power minus 5. 1.8 into 10 to the power minus 5. So the correct option is C. Okay, yeah. Next question, question number 47. A uniform magnetic field of strength B equal to 2 millitesla. Okay, sorry, this is not millitesla, this is microtesla. Okay, microtesla, M means micro, exits vertically downwards. These magnetic field lines pass through a closed surface as shown in the figure. Okay, so this is the given figure. The closed surface consists of a hemisphere S1. So this is the hemisphere. The surface area is S1. A right circular cone S2 and a circular surface S3. Okay, so this is the circular surface, surface area of the circular surface. Here the surface area of the circular surface is S3 and the cone surface will be S2. Yeah. The magnetic flux through S1 and S2 respectively. Okay, we need to find magnetic flux through here S1, that is when magnetic field passes through the hemispherical surface and cone surface, right? Okay, what is magnetic flux? Magnetic flux is equal to B dot A, right? What is B? Magnetic field vector. A is area vector. So phi is equal to BA cos theta. What is theta? Theta is angle between magnetic field vector and area vector. Okay, yeah. So here R is given, right? That is the radius of this circular surface, right? Isn't it? Okay, how to find the magnetic flux? Okay, I will redraw this diagram. Okay, from this point of view, this is how the given shape looks like, right? So this is R equal to 10 divided by root pi meter, right? Isn't it? So this is how the magnetic flux passing through the given surface areas, right? Isn't it? So the magnetic flux passing through the hemispherical surface and the cone surface is equal to magnetic flux passing through the circular surface, right? From this point of view, the magnetic flux passing through the hemispherical surface and cone surface is equal to magnetic flux passing through this circular surface, right? Isn't it? That is S3, right? So phi is equal to, what is the value of magnetic field? 2 microtesla, right? So 2 into 10 to the power minus 6 into magnetic field is coming in, right? But surface area or area vector is opposite to the direction of the magnetic field, right? So here area is pi into 10 divided by root pi whole squared, right? Into cos theta. Theta is 180 degree. So this will be minus 1. Cos 180 degree is minus 1. So now phi equal to here 2 into 10 to the power minus 6 into pi into 100 divided by pi. Pi will get cancelled, right? 100 into 10 to the power minus 6 is 10 to the power minus 4, right? Isn't it? So phi equal to 200, right? So 200 into 10 to the power minus 6, right? 200 into 10 to the power minus 6. So if it is 200 into 10 to the power minus 6, so this is not in meter, right? So this has to be in centimeter, right? Centimeters, then this will be 10 to the power minus 4, right? Isn't it? So phi equal to, actually here 200 into here, this will be 10 to the power minus 4, right? So 20 into 10 to the power minus 6 Weber, okay? Or here this is minus 20 micro Weber, okay? What is the magnetic flux passing through the cone surface? That is plus 20 micro Weber, right? Why? Because area and magnetic field both are in same direction. So option A is the correct answer. Phi S1 equal to minus 20 microweber and phi S2 equal to plus 20 microweber. Yeah. Next question. Question number 48. In the figure, a conducting ring of certain resistance is falling towards a current carrying straight long conductor. The ring and conductor are in the same plane. Then the option A, induced electric current is 0. Okay, let's see. this is the direction of the current, right? That is towards right. So what is the direction of the magnetic field at this point or at this point or at this point, this point? The direction of the magnetic field is outward from the plane, right? Applied right hand thumb rule. The direction of the magnetic field is outward from the plane. Here the ring is falling towards the current, right? Sorry, current carrying conductor, right? Or current carrying wire. So the magnetic flux passing through this ring or this coil increases, isn't it? Magnetic flux passing through this coil increases. So according to Lenz's law, here the induced current will be produced in such a way that it opposes the increase in magnetic flux, right? So in which direction induced current will be produced? In clockwise direction, right? So in clockwise direction induced current will be produced, right? So apply right hand thumb rule. Here the direction of the magnetic field is into the plane due to the induced current, right? So it is opposing the increase in magnetic field, right? So the direction of the induced current is in clockwise direction, isn't it? So option C is the correct answer. Okay, yeah. Next question, question number 49. An induced current of 2 ampere flows through a coil. The resistance of the coil is 10 ohm. What is the change in magnetic flux associated with the coil in 1 millisecond? Okay, the induced current is 2 ampere, right? I induced equal to 2 ampere, right? The resistance is also given, R, right? So we need to find the magnetic flux change in magnetic flux associated with the coil in 1 millisecond. So what is induced current? Induced current E equal to induced EMF divided by resistance of the coil, R. So induced current is given, right? Resistance of the coil is given. So how to find magnetic flux? So induced EMF is rate of change of magnetic flux or change in magnetic flux over change in time. Okay, change in magnetic flux over change in time divided by R. So we need to find delta phi, that is change in magnetic flux. So delta phi is equal to I R into delta T. So now delta phi equal to I is 2 ampere, R is 10 ohm, delta T is 1 millisecond, that is 10 to the power minus 3. So now delta phi equal to 20 into 10 to the power minus 3, right? So that is 2 into 10 to the power minus 2 Weber. This is the change in magnetic flux associated with the coil in 1 millisecond. So the correct option is B. Okay, yeah. Question number 50. A square loop of side length A is moving away from an infinitely long current carrying conductor at a constant speed V as shown. Okay, so this is the given diagram. Okay, this is the coil, square coil. The side is A, it is moving with speed V, right? And this is the current carrying wire carrying current I, right? Let X be the instantaneous distance between the long conductor and side AB. Yeah, this is the instantaneous distance. The mutual inductance M of the square loop long conductor pair changes with the time t according to which of the following graphs? Okay, we need to find mutual inductance versus time graph, right? As square coil moves away from this wire, the current carrying wire, what happens? The magnetic flux passing through the coil decreases, right? So that is mutual inductance will also be decreases, right? So mutual inductance depends on time, right? Here I am solving this by qualitative only. Okay, by qualitative method we can easily solve. You don't need to prove this and all. Okay, so now here mutual inductance decreases with the time, right? Isn't it? Mutual inductance decreases with the time as it moves away from the current carrying wire. So M is inversely proportional to time t, right? So the graph of M versus t will be inverse graph like this, right? So the correct option is A. Okay, yeah. Question number 51. Which of the following combinations should be selected for better tuning of an LCR circuit used for communication? Okay, for better tuning, here the Q factor of the circuit must be very high. Okay, Q must be very high. Q value must be very high. Okay, or quality factor The value of the quality factor must be very high. Okay, so what is the formula of the quality factor? Q equal to 1 divided by R into root of L divided by C, right? So now you have to check every option. Okay, so if you check every option, you will get the high value for Q at the R equal to 15 ohm, L equal to 3.5 Henry, and C equal to 30 microfarad. Okay, so the correct option is D. Okay, yeah, check every option, you will get this answer. Okay, in option D. Next question, question number 52. In an LCR series circuit, the value of only capacitance C is varied. The resulting variation of resonance frequency F0 as function of C can be represented as. Again, this one is also direct question, right? Isn't it? So here XC equal to 1 divided by omega C, right? So XC is equal to 1 divided by omega is 2 pi F0 into C, right? So F0 into XC equal to 1 divided by 2 pi, or we can write it as here F0 equal to 1 divided by XC into C, right? So from this I can conclude that F0 is inversely proportional to C, right? So the graph of F0 versus C will be inverse like this, right? Isn't it? So the correct option is C. Okay, yeah. Next question, question number 53. The figure shows variation of R, XL. What is R? R is resistance, XL is inductance, okay, sorry, inductive reactance, and XC capacitive reactance with frequency F in a series LCR circuit. Then for what frequency point is here, then what frequency point is the circuit capacitive? Okay, so at what frequency the circuit is capacitive, right? So when will be the capacitive circuit? We will get here when XC is greater than XL, then the circuit is capacitive. When XC is greater than XL, the circuit is capacitive. Okay, so at what frequency or at what point the frequency XC is greater than XL? At A, right? See here at A, XC is greater than XL, right? So the correct option is C. Understood? Yeah. Next question, question number 54. The electromagnetic waves are incident normally on a perfectly reflecting surface having surface area A. If I is the intensity of the incident electromagnetic radiation and C is the speed of light in vacuum, the force exerted by the electromagnetic wave on the reflecting surface is. Okay, so this is the perfectly reflecting surface. Electromagnetic radiation hits on this perfectly reflecting surface, right? So what is the pressure created by this electromagnetic radiation? So P equal to force exerted by the electromagnetic radiation divided by surface area of the given surface, right? So what they are asking here, they are asking force exerted by the electromagnetic wave, right? So force F equal to here pressure A into area, pressure P into area A, right? So now force F equal to pressure P. For perfectly reflecting surface, the pressure or radiation pressure will be 2I by C into A. So force exerted by the electromagnetic wave equal to 2I A divided by C. So the correct option is A. Okay, yeah. Next question, question number 55. The final image formed by an astronomical telescope is, here the final image formed by an astronomical telescope is virtual, inverted and magnified. Okay, virtual, inverted and magnified. So the correct option is D, memory based question. Okay, yeah. Question number 56. If the angle of minimum deviation is equal to angle of prism for an equilateral prism. Okay, here we have equilateral prism, that is 60 degree, 60 degree and 60 degree, right? So angle of prism equal to 60 degree. So angle of minimum deviation, according to the question, angle of minimum deviation is equal to angle of prism, right? For an equilateral prism. Then the speed of light inside the prism is, okay, we need to find speed of light inside the prism, right? Okay, So first we need to find refractive index of the prism material, right? Why? So if you find the refractive index of the prism material, then we can easily find the speed of light inside the prism, right? Isn't it? So refractive index of the prism material mu equal to c, that is like speed of light in vacuum, divided by v. V is speed of light in prism material, okay, or inside the prism. Okay, let us find mu, right? So mu equal to, we know the formula, right? Sine of a plus delta m divided by 2, delta m is angle of minimum deviation, divided by sine of a by 2. Okay, so now mu equal to sine of a plus delta m, that is 120 degree. 120 degree divided by 2 is 60 degree, right? So sine 60 degree divided by sine 30 degree. Yeah, sine 60 degrees root 3 by 2, sine 30 degrees 1 by 2. So 1 by 2, 1 by 2 will get cancelled. Mu equal to root 3, right? So now here V equal to C divided by mu, right? So V equal to C is 3 into 10 to the power 8 meter per second divided by mu is root 3. So V equal to root 3 into 10 to the power 8 meter per second. So this is the velocity of the light in prism material. So the correct option is C. Okay. Yeah. Next question, question number 57. A luminous point object O is placed at a distance 2r from the spherical boundary separating two transparent media of refractive indices n1 and n2. So here the refractive indices are given, right? n1 and n2, right? So this is the curved surface. The radius of the curved surface is r. Okay, where r is the radius of the curvature of the spherical surface. If n1 equal to 4 by 3, n2 equal to 3 by 2 and r equal to 10 centimeter, the image is obtained at a distance from P is equal to. Okay, so this is the point object, right? So this point object O is 2r distance from the P, right? So here we need to apply this formula, right? For curved surface, right? The formula will be n2 divided by V minus n1 divided by U equal to n2 minus n1 divided by r, right? So what is the value of n2? 3 by 2. So 3 by 2v minus n1. n1 is 4 by 3, right? So 4 divided by 3 into u. U will be minus 2r, right? So why it is minus 2r? Because the direction of the measurement of u is opposite to the direction of the incident ray, right? So minus 2r. So this will be plus 4 by 3 by 2r, right? Equal to n2 minus n1, that is 4 by 3 minus 3 by 2 minus 4 by 3, right? n2 is 3 by 2, right? Isn't it? Okay, n2 is 3 by 2. So 3 by 2 minus 4 by 3 divided by r. So r equal to 10 centimeter. So now substitute the values. That's it. So 3 divided by 2v plus 4 divided by 3 into 2 is 6. 6 into 10 is 60. 60 equal to 3 by 2 minus 4 by 3 divided by 10. So now solve this. You will get v equal to minus 30 centimeter. So what is the meaning of negative sign? The negative sign indicates that the image in the rarer medium. Okay, image formed in the rarer medium. So the correct option is A, 30 centimeter, and it formed in the rarer medium. Yeah. Next question. Question number 58. An equiconvex lens of radius of curvature 14 centimeter is made up of two different materials. Left half and right half of vertical portion is made up of materials of refractive index 1.5 and 1.2 respectively, as shown in the figure. Okay, so this is the equiconvex lens. Okay, this equiconvex lens made up of two materials, two different materials. Okay, one material has refractive index 1.5 and another has 1.2. Yeah, if a point object is placed at a distance of 40 centimeter, calculate the image distance. Okay, we need to find image distance, right? And object distance is given. Yeah, so but first we need to find the focal length of this equiconvex lens, right? It is made up of two different material, isn't it? So first apply lens maker's formula for both materials, for both different material, then find the net focal length. Okay, so now lens maker's formula, 1 divided by f equal to mu minus 1 into 1 divided by r1 minus 1 divided by r2, right? So now for this part, right, so this is r1, okay, now this is r2, understood? Yeah. Now for the first material, 1 divided by f1 is equal to mu1 is 1.5, right? So 1.5 minus 1 is 0.5, right? 0.5 into 1 divided by r1. So what is the value of r1? Plus 14 centimeter or minus 14 centimeter? It is plus 14 centimeter, right? Why it is plus 14 centimeter? Because the direction of measurement of r1 is same as the direction of the incident ray, right? Here, somewhere here, we have placed the object, okay, 40 centimeter from the equiconvex lens, right? So 1 divided by r1, that is 14 centimeter, and 1 by r2 is infinity. Sorry, 1 by r2 is 0. r2 is infinity, 1 by r2 will be 0. Now 1 divided by f2 is equal to, here mu minus 1, that will be 0.2 into 1 by r2, 1 by r1 minus 1 by r2, 1 by r1 minus 1 by r2 is 1 by 14 only, right? So r1 is infinity, r2 is minus 14, right? So 0.2 by 14. So now 1 by f, 1 by capital F is equal to 1 by f1 plus 1 divided by f2. So 1 divided by f equal to 1 divided by f1, that is 0.5 divided by 14, right? So 0.5 by 14 is 1 by 28, right? Plus 1 divided by f2. 1 divided by f2 will be 0.2 by 14. What is 0.2? 0.2 is 1 by 5, right? So 5 into 14 is 70, right? So 1 by 70. Okay, we have the focal length, the net focal length, right? Or focal length of this equiconvex lens, right? So we need to find V, image distance, right? Okay, let us find f only. Here 1 divided by f is equal to, here 70 plus 28, that is 98 divided by 28 into 70, right? So now which is equal to 1 divided by V minus 1 divided by U, right? 1 divided by V minus 1 divided by U. So what is the value of U? U equal to minus 40 centimeter, right? Isn't it? V equal to minus 40 centimeter. So now 1 divided by F is equal to 98 divided by 28 into 70, right? Which is equal to 1 divided by V, right? Minus 1 divided by minus 40, that is 1 divided by 40. Okay, so now solve this. Okay, solve this, we will get V equal to 40 centimeter. V equal to 40 centimeter. The correct option is D. Okay, yeah. Next question, question number 59. A galaxy is moving away from the Earth so that the spectral line at 600 nanometer is observed at 601 nanometer. Then the speed of the galaxy with respect to the Earth. So this is from the Doppler effect, right? Okay, we need to find speed of the galaxy with respect to the Earth, right? So we know that delta V divided by C is equal to delta lambda divided by lambda, isn't it? So now delta V is speed of the galaxy with respect to the Earth, equal to C is speed of the light in vacuum, that is 3 into 10 to the power 8 into delta lambda. Delta lambda is 601 minus 600 nanometer, so that will be 1, right? So that will be 1 divided by 1 nanometer, okay, divided by 600 nanometer. Lambda is 600 nanometer. Nanometer will get cancelled. Now this will be 200, right? So delta V is equal to 500 kilometer per second. So the correct option is A. Okay, and next question, question number 60, and the last question. 3 Polaroid sheets are coaxially placed as indicated in the diagram. pass axis of the polarides 2 and 3 make 30° and 90° with the pass axis of polaride sheet 1. Okay, so this is the polaride 1, okay, and the second and third polaride makes an angle 30° and 90° with the pass axis 1, right? If I naught is the intensity of the incident polarized light entering sheet 1, the intensity of the emergent light through sheet 3 is. Okay, so when the light passes through the first polaride, what happens? Here the intensity becomes half, right? That is I naught by 2. When it passes through the second polaride, the intensity I will be equal to I naught by 2 into cos square theta, right? So I equal to I naught by 2 into cos square theta is 30°, right? So cos 30° is root 3 by 2, right? So I equal to I naught divided by 2 into root 3 by 2 whole square is 3 by 4. Okay. So now it passes through the third polaride, right? So here what is the value of theta? Theta is 60°, right? 60° with this axis, right? This one, isn't it? So now I dash is equal to here I naught into 3 divided by 8 into cos square 60°. Cos 60° is 1 by 2. So 1 by 2 squared is 1 by 4, right? So 3 I naught divided by 32. So this is the intensity of the emergent light when it passes through the third polaride. So option B is the correct answer. Yeah, that's it. Okay, thank you. Thank you so much for watching this video. If you love this video, please like and share. And if you want to watch more such videos, please subscribe. Thank you.